Hello and welcome to the OCR Further Maths videos for Pure Core. This is Matrices 5, Matrices and Simultaneous Equations. And this is 5.3, 3 simultaneous equations, no unique solution. So, if you solve simultaneous equations in 3D, there are 5 possibilities for how the 3 distinct planes can be arranged. What are they? Try sketching or try using 3 sheets of paper and thinking about the different ways those pieces of paper can act as planes. So let's go through the possible solutions. So if M is the zero matrix, this is a trivial case but it's worth talking through, then all points are mapped to the origin and there is no solution. If the determinant of M is not equal to 0, there is a unique solution, just like when we did 2 simultaneous equations, because it means that M is non-singular and an inverse does exist. These 3 planes will have a single common point, as we saw in the previous video. If the determinant of M equals 0, then there is no unique solution, and M is singular and therefore no inverse exists. There may be an infinite number of solutions. The equations are consistent, and that means that the 3 planes share a common points line. So we have a sheaf of planes. So for example, they may look like this, and you can see there, here, the common line of points. There may not be any solutions, the equations are inconsistent, and this will happen when all 3 planes are parallel and distinct. So you can see there 3 parallel distinct planes. You could also have 2 planes that are parallel and distinct that are crossed by a 3rd plane, or you could have a triangular prism of planes. So have a play with your 3 pieces of paper and think about these situations. Now we need to be able to distinguish between these cases. In your textbook or on Integral there are some written examples, but we're just going to look at some examples of how to distinguish between these. So here we have parallel planes. If planes are parallel, they have the same normal direction, and you'll go into this more in the work on vectors. That means that they will have the same x, y and z coefficients, or multiples of those, and you can check whether it's 2 or 3 planes that are parallel. So in this first case here, we have all 3 planes are parallel, and in this one here, we just have 2 parallel planes and one that passes through them. You could also have, if you've ruled out them being parallel, you can tell if it's a sheaf because the equations are consistent and they give an infinite number of solutions. Or you could have a prism because the equations are inconsistent with no solutions. You can see in this one here with the infinite solutions, there is this line here where we have solutions where all 3 planes are equal. Here we can only find 2 planes with common points, not all 3 planes. That's the end of the videos on Matrices 5, Matrices and Simultaneous Equations.